Okay, here we want to talk about the type of ionizing radiation. So there are three types of radioactive radiation, which are ionizing radiation. Okay, they are alpha radiation, beta radiation, and gamma ray. Okay, so these three, alpha radiation, beta radiation, and gamma ray, they are called radioactive radiation because they are produced through radioactive decay. That means they are produced from unstable nucleus that decay to become more stable nucleus. Okay, so you want to look at more detail about them. So alpha radiation, they are actually helium nucleus. So why is it that we call it helium nucleus? Because alpha radiation have 2 proton and 2 neutron, which is the same as the nucleus of helium. Okay, beta radiation is high speed electron. That means the electron that move at a very high speed. Okay, shooting out from the nucleus. And then gamma ray is electromagnetic wave. Okay, so what is the charge of particle? Alpha radiation, because it has 2 proton and has no electron, so it is positively charged. Beta radiation is electron, so it is negatively charged. Gamma ray, it is neutral. Okay, alpha radiation, because it has 2 protons, so it has positive 2 charge, so the ionizing power is high. While beta radiation is electron, and the negative charge is only -1, so the ionizing power will be moderate. Gamma ray has no charge, so the ionizing power is low. Okay, gamma ray has ionizing power because gamma ray have energy. So when gamma ray collide with particles, so the energy can be transferred from the gamma ray to the particle. So when the particle absorbs the energy, the electron may escape from the surface of the particle. So when the particle lose electrons, so it becomes positively charged. Okay, next is penetrating power, okay, or penetration power. Okay, as you can see here, this one, the red color one, this is the alpha particle. So the alpha particle or the alpha radiation cannot penetrate through paper. Okay, so the penetrating power of alpha particle is low. Beta radiation, it can penetrate through paper but can be blocked by a 3mm aluminum, so the penetrating power is moderate. Of gamma ray, it can penetrate through paper, penetrate through aluminum, and can only be blocked by a 10cm thick lead. So that means the penetration power of gamma ray is very high. Okay, alright, so let's look at let's look at deflection by electric field. So this is very simple. Alpha particle have 2 proton. It is positively charged, so it will be attracted by the negatively charged plate, while the positively charged plate will attract the beta particle because the beta particle is negatively charged. Okay, negatively charged, so it attracts to the positive plate. Okay, so you see the alpha particle, the degree of bending, okay, the degree when it change direction is less compared to the degree when the beta particle change direction. So why is it like this? The reason is because alpha particle have higher mass. Okay, the mass of the alpha particle is higher because it has 2 proton, 2 neutron. So so the mass of the alpha particle is much higher compared to mass of electron. So because alpha particle have very high mass, so it will be more difficult for it to change direction. So it change direction slowly. For beta particle, it is electron, which is very small mass, so it can easily change direction. So as you can see, the degree or the rate of change of direction is very high. Okay, alright, so next is the deflection by magnetic field. Okay, so in this part you see that, okay, if north pole, the magnet, we have magnet, okay, north pole on this side, south pole on this side, okay, and when the radiation pass through, okay, the alpha particle will bend upwards and the beta particle will bend downwards. Okay, for the reason why is it able to bend up or bend down, you don't have to worry about that in the Form 3 level. You will learn the reason when you go to higher level. Okay, when you go from 4, Form 5, you will learn about this. Okay, and then as you can see, again same like just now, the change in direction of the alpha particle, it happened more slowly. Change direction slowly, change direction. So same direction, same reason, because alpha particle have higher mass compared to beta particle. So beta particle with the very small mass, the beta particle can change direction very quickly. Okay, for both of these, electric field and also magnetic field, the gamma ray, okay, gamma ray is not affected. Okay, the reason is because gamma ray have no charge. Okay, the charge is neutral, okay, or no charge. So that's why it's not affected by electric field, also not affected by magnetic field. Alright, so let's look at this, the exercise. Okay, so alpha particle, the charge is positive, and then beta particle, the charge is negative. Gamma ray is neutral. Mass, alpha particle large, beta particle small, gamma ray is no mass. Common characteristic, the alpha particle, it is an helium nucleus. Beta particle is electron, gamma ray is electromagnetic wave. Okay, ionizing power, alpha particle is high, beta particle is moderate, and gamma ray is low. Penetrating power, alpha particle low, beta particle is moderate, and then the gamma ray is high. Deflection by magnetic field, alpha particle, okay, we say that the bend to negative plate with small deflection, and then this beta particle is bent to positive plate with large deflection. Okay, and gamma ray does not deflect. Okay, alpha particle small deflection, beta particle is large deflection, and then again the gamma ray does not reflect. Okay, next. Okay, diagram 5 show penetrating power of 3 types of radiation. So P cannot penetrate paper, so that means it is alpha particle. Okay, Q can penetrate paper but cannot penetrate aluminium, so this is beta particles. While gamma ray can only be stopped by lead, so This is gamma ray. Okay.